Good morning, students. We will try to solve a heat flow equation, the displacement of heat flow equation in partial differential equation. This is a second topic in the unit. Consider a straight bar with a uniform cross section and the homogeneous material. We wish to develop a model for the heat flow through the bar. So we are going to find out the U of x comma t, which is the temperature, depends on position and temperature. On the cross section located at x and time t, we shall follow some basic principles of physics. One is rate of change of displacement, another one is rate of change of time. So there are two variables. One is partial differentiation with respect to t, another one is partial differentiation with respect to x. The latter is called as a gradient. Both refer the change. Okay, change in a unique direction. The amount of heat per unit time flowing through a unit cross-sectional area is proportional to du by dx with a constant of proportionality k of x called thermal conductivity of the material. So this is the definition for your thermal conductivity. So this is the expression for your thermal conductivity. Heat flow in a thermal conductivity, heat flow in the slab. So this is your thermal conductivity. And this quantity of energy, heat energy, depends on area of the slab, time. So time is very important. Change in temperature, that is also very important. And gradient. So this is your gradient. Heat flow is always from points of higher temperature to lower temperature. The amount of heat necessary to rise the temperature of an object of mass m by an amount del u is a C of x times m del u, where C of x is known as specific heat of the material. That should study the amount of heat h of x flowing from left to right through a surface area of a cross section during the time interval del t given by this formula. So similarly, we can have x plus del x. So we can have x plus del x. This is your x. So similarly, we can derive the formula x plus del x. So that formula goes like this. So if on the interval x comma x plus del x during the time del t, additional heat sources were generated, say for example chemical reactions, heater or electric currents with energy density q of x comma t, then the total change in the heat del E is given by the formula. Okay, this formula. So this is your general formula, and of course when where k, c, rho are they are constants. Okay, if k, for example, if k equals 1, that will give us d squared u by dx squared. We are going to keep k as beta squared, and this becomes d squared u by dx squared. See here we have d squared u by dx squared, this term, and we have du by dt. All the other terms we can keep it as 1. So this is your equation of a heat flow. So this is heat flow equation. What are the boundary conditions? So we are going to have some boundary conditions. Boundary conditions are given by this slide. So we have the boundary conditions exactly like this. U of x comma t. So x is 0. So 0 comma t, which is equal to u of L comma t, which is equal to 0. Here x equal to 0, here x equal to L. L is the length of the slab. And you have x comma 0, where t equal to 0, which is equal to f of x. So we have only two boundary conditions. This one and this one, and so we have three boundary conditions. This one and this one and this one. So we have three boundary conditions. Now let us solve one problem. Find the solution of the equation du by dt, which is equal to alpha squared d squared u by dx squared, which satisfies the condition. Which satisfies this condition. U of 0 comma t, which is equal to 0. U of L comma t, which is equal to 0, where t is greater than 0. And this is the condition. Boundary conditions are given. So x lies between 0 and L by 2, we have x. X lies between L by 2 and L, we have L minus x. So this is the equation given in the problem. So this equation, according to this equation, the solution is given by this expression, equation 1. So we have the heat flow equation. We are going to find out U of x comma t, which is the solution of this differential equation, partial differential equation, and the solution is given by this. Now we will have to use the boundary conditions. as I said earlier, there are three boundary conditions: u of 0 comma t equal to 0, u of L comma t equal to 0, u of x comma t x comma 0, which is equal to this condition. Now we have to apply the first condition in equation 1. So this is equation 1. Just apply equation in equation 1 first condition, that is x equal to 0, u equal to 0. X equal to 0, so this becomes cos 0 is 1, so we have a, sin 0 is 0. So a times e power minus alpha square lambda square t. Okay, so with this is equal to 0. This term cannot be equal to 0, so a equal to 0. So substituting a equal to 0 will give us e of x comma t equal to b times sin lambda x e power minus alpha square lambda square t. This is equation 2. Now we will go for the second boundary condition. Second boundary condition is x equal to L, u equal to 0. So u equal to 0, which is equal to second boundary condition. Wherever you find x, you have to substitute L. So b sin lambda L e power minus alpha square lambda square t. So this refers sin lambda L equal to 0, which is equal to sin n pi. B cannot be equal to 0 as we have seen earlier. So lambda L equal to n pi, lambda equal to n pi by L. You substitute for lambda, which is equal to n pi by L. So that will give us equation 3. So we have now u of x comma t, which is equal to b times sin n pi x by L e times e to the power minus alpha squared n squared pi squared by L squared t. Okay, equation 3. Now this is most general solution. So general solution is given by this, your Fourier series. Okay, half range Fourier series sine term, which is given by this equation 4. We have to find out the value of Bn. So now u of x comma 0, the third boundary condition, t equal to 0, we have to substitute this and we will have this equation, equation 5. When I am going to substitute t equal to 0, e power minus 0, 1 by e power 0, answer is 1. So we have bn sin n pi x by L, so bn sin n pi xl, which is equal to this. Okay, which is equal to, so this is your f of x. In this interval, your f of x equal to x. In this interval, your f of x is nothing but L minus x. So we have 0 to L. So we have two limits, 0 to L by 2, then another limit will be L by 2 to L. So we know that the constant Bn equal to 2 divided by L, 0 to L, f of x sin n pi x by L dx. Okay, where f of x equal to x in this interval and f of x equal to L minus x in this interval. So we have separated. We have separated. One is x, another one is L minus x. Okay. Now x times sin n pi x by L dx integration. We have to use Bernoulli's formula. And here too we have to use Bernoulli's formula. I am going to keep u as x here. And we are going to differentiate. This becomes 1. Again we have to differentiate, b is 0. So we have only see here this term and this term only, we have only two terms. Only we have two terms. What about here? L minus x. We are going to keep this as u equal to L minus x. We have to differentiate u prime, that will give us minus 1. Again we have to differentiate, that will become 0. Only we have two terms. Only we have only two terms. What about v? So your v is nothing but sin n pi x by L. Okay. There's a mistake here. Your v is nothing but v is nothing but sin n pi x by L. So we are going to differentiate. So that will become v1. This is your v1. It is not v as such. It is v1. There's a mistake here. This is your v2. So v1 equals minus L divided by, you have to differentiate this. That becomes minus cos n pi x by L. So that will give us, no, you have to integrate. Sorry, we will have to integrate. So this term for differentiation and this term for differentiation, you have to integrate. So this is your v equal to this one. v1 is the integration. So v1 equals minus cos n pi x by L divided by n pi by L. So that will give you minus L divided by n pi cos times cos n pi x by L. Okay. Now again you have to integrate. When I am going to integrate, that will give me this. So cos integration, that will give me sin n pi x by L divided by n pi by L. Already one L divided by n pi is there, so that will become L square divided by n square pi square. Now according to the Bernoulli's formula, you have to substitute. So you have u times b1, u prime times b2. Similarly here for the next one, u times b1, u prime times b2. So we will have this expression. Only two terms alone exist. Okay, now you have to substitute 0 to L by 2 for the first one and L by 2 to L for the second one. So you have to substitute for first one, which is nothing but your L by 2. So L by 2 becomes, we have L by 2, 0 to L by 2. Here it is L by 2 to L. Now you have to substitute, this becomes L by 2. Here you substitute L by 2, L by 2. L will get cancelled. We have cos n pi by 2. Cos pi by 2. This term becomes cos 90. It is 0. So we have 0 here. So we'll see one by one. So we have now minus L by 2. So we have minus L by 2. And here L n pi is there. Cos n pi by 2. See cos n pi by 2. Okay. Next term will be this one. You have to substitute the upper limit. So that will give us L by 2. L will cancel. Sin n pi by 2. So sin n pi by 2. Substitute the lower limit. Lower limit here. X, instead of x, you have to substitute 0. So this term will become 0. Sin 0, 0. So these two terms will become 0. 0, 0. Okay. Now you just substitute. For the second term, you just substitute L first. L minus L, 0. Substitute here L will cancel. Sin n pi, this is 0. Sin n pi is 0. Okay. Now you have to substitute the lower limit. When you are going to substitute the lower limit, that will become L by 2. See, we have L minus L by 2. L minus L by 2. So that will give me plus L by 2. Okay. So next term will be, you are going to substitute here L by 2. So this is L by 2. L will cancel. Sin n pi. So this term will go off. So this term will see L by 2. So we have now L by 2. So that will become L will cancel. We have n pi by 2. And this term will become sin n, L will go off, you have sin n pi by 2. Okay. So we have now the first term is here, second term is here, and this is your third term, and this will be your fourth term. And this term will get cancelled. See here, this term and this term are similar terms, they will get cancelled. This term plus this term will give us 2 times. So we have Bn equal to 2 divided by L, 2 times L square divided by n square pi squared sin n pi by 2. Okay. Is it okay? So now we know that we have found out now Bn. So substituting in equation 5 will give us this expression. So this is the solution. So instead of Bn, you substitute here. So this is the complete solution of the heat flow equation for the problem. So V of x comma t equal to this one. Is it okay? So we have 2 to 4. This L squared and this L will cancel. We have L divided by n squared pi squared sin n pi by 2 sin n pi x by L times e power this term e power minus alpha squared n squared pi squared t divided by L squared. So this is the complete solution. Now we'll solve other problem for the heat flow equation. du by dt equal to a squared d squared u by dx squared, and there are 3 boundary conditions given us here. Here it is given as v of x comma t equals 4 sin pi px by a. It is given. In the earlier problem it was x and L minus x. Can you remember? In the earlier problem, x and L minus x. But here it is given as your f of x is nothing but 4 times sin pi px divided by a. Okay. So we have now the equation and the solution is given by this. We should apply the first boundary condition, which is nothing but first u equal to 0, x equal to 0. So u equal to 0, x equal to 0, that will give us this. So we have now u equal to a sin kx e power minus k squared a squared t. So this implies that sin k equal to 0, sin k equal to 0 is nothing but sin n pi, where k equals n pi by a, k equal to n pi, ka equal to n pi, so k equal to n pi by a. You substitute here in the previous equation, that will give us, instead of k you substitute, so u of x comma t equal to a times sine, instead of k you have to substitute pi by a, see pi by a x, e power times e power minus n pi by a whole square a square t. So this is your complete equation. Now substitute the other boundary condition, t equal to 0. T equal to 0, this term will become 1. So this becomes 4 sine, this becomes 4 sine pi x by a, which is equal to a sine n pi. It is given us, see it is given as this. Your f of x is nothing but 4 sine pi px by a. So 4 sine pi px by a, which is equal to, when t equal to 0, this term. So this term becomes a sine n pi a x, e power 0 is 1. So comparing these two, that will give us a equal to 4. Substituting n equal to p, that will give us u equal to, you have to substitute here, so n equal to p and a equal to 4, that will give us u equals 4 sine, instead of n you have to substitute p, so p pi by a x, x is here, okay, there's a mistake here, x is here, e to the power minus, instead of n substitute p, so p squared pi squared by a squared by t. Okay, this a squared and this a squared will cancel, so we have e squared e to the power minus p squared pi squared t. So that is your complete answer. So this is a solution of the given equation. The last problem, last but one, you are going to solve this one, and conditions are given. Conditions are given. The boundary conditions are, one is 0, another one is x equal to L, again it is 0 for all values of t, and the last one is t equal to 0, we have u0. So we have to substitute f of x equal to u0. So this is the equation, given equation, and the solutions are given by this. So we have the solution here. The most general solution is given by this. We will have to apply first boundary condition. We will see one by one. So now, so these are the boundary conditions. So t equal to 0, we have u0 in this interval. Okay, we will solve one by one. So now, right hand side represents half range sine series, we know already. So Bn equal to 2 divided by L, 0 to L, f of x sine n pi x by L dx. So instead of, as I said earlier, f of x is nothing but u0. So you have to substitute f of x is nothing but u0. So 2 divided by L, 0 to L, sine n pi x by L dx. And of course you know already all those things. See here, very simple. So we have the complete equation. This is a solution of this equation. We will have to substitute t equal to 0. We will have to substitute t equal to 0. So this becomes 1. We have dn sine n pi x by L. Okay. This is simple. You will have to, according to the boundary condition, which is equal to u0. Which is equal to u0. So your f of x is nothing but u0 at t equal to 0. So that's why we have obtained this. And your bn is nothing but the constant using half range sine series, that will give us this. Now u0 sine n pi x by L on integration, that will give us minus cos n pi x by L divided by n pi by L, 0 times L. So that will give us, you substitute L here, L and L will cancel, 2 u0 by n pi. Okay, so that will give us cos n pi by L. Instead of n pi, you have to substitute minus 1 to the power n. Substitute the lower limit, that will give us 0. Cos 0 is 1. Or otherwise, you remove the minus sign. First substitute 0, then substitute L. That is very simple. So we have cos 0 is 1. Okay, so 1 is cos 0 is 1. Substitute the lower limit. Now it has become lower limit. So we have now 1 minus 1 to the power n. As usual, the same argument when n is odd. When n is even. When is even, this becomes 0. When is odd, this becomes 2 times. Can you remember? Suppose n equal to 1. This becomes 1 minus 1 to the power n is minus 1. Already 1 minus is there. So 1 plus 1 is 2. So 2 times 2. That will give us 4 u0 by n pi. 4 u0 by n pi. When n is odd. When n is even, this becomes 0. when n is even, for example 2, just take n equal to 2, this becomes 1 minus 1 square, that will give us plus 1, already 1 minus is there, so 1 minus 1, 0. Now when n is odd, this is your expression, so instead of bn you have to substitute this. Okay, now when for n is even, for n is odd, you have to write 2n minus 1. You can write, instead of n, you can write general solution, 2n minus 1 times pi x by L, when n becomes 2n minus 1. So e to the power minus, instead of n, you are going to substitute 2n minus 1. So n squared becomes 2n minus 1 whole squared, and rest of the expression. So your complete solution is this for the problem. So this is your heat flow equation. Okay, for the problem which is given in the slide. Now you go for the last problem. A rod 30 centimeter long has its end A and B, which is at 20 degrees and 80 degrees. So we have a rod like this, and this is kept as 20 degrees and this is kept as 80 degrees until the steady state conditions prevails. So we have a steady state condition reaches. The temperature at each end reduced to 0 degree and kept so, and find the displacement. So we are going to find out u of x comma t. So one end is kept as 20 degrees, the other end is kept as 80 degrees. There is a steady state formula which is equal to u equals b minus a times L, a by L times x plus a. B is 80, a is 20. Length of the rod is given as 30 centimeters, so 30, x plus 20. So that will give us u equals 60 divided by 30, x plus 20. So u is a function of x comma small t. So this is your time small t, which is equal to 2x plus 20. So that is the end. We will start today. We will see in the next class. Thank you, students.